So, class, welcome to lecture number 11th of the course PSP. So, this will be the last lecture of Unit 1 because Unit 1 is the lengthiest unit of the course. So, in the previous two lectures, we studied load curve, load duration curve, what is demand, this diversity factor, what is load factor, what is maximum demand. Okay, and this maximum demand, it has been explained with the help of this load duration curve. Without load duration curve, it is difficult to explain what is this load maximum demand. Then we talked about this plant capacity factor, plant use factor, or plant use factor. Okay, so and we saw that this maximum demand, it will be always less than this load factor will always be less than unity, and this diversity factor, it will always be greater than unity. So today we will see one or two more terms. So first, let me say that this if higher the load factor and diversity factor, higher the load factor and diversity factor, LF means load factor, and this diversity factor, lower will be the overall cost. Lower will be the cost. Okay, lower will be the cost per unit of hope the screen is this camera is, everything is visible. So I am saying higher the load factor and diversity factor, lower will be the cost per unit of power generated. Okay, so means instead of higher, I should use better the load factor and diversity factor, higher will be the cost per unit generated. I will explain it later. So before that, this I would like to explain, means yesterday we studied about the load curve. So but what information means this load curve gives, that was not highlighted, means that was not means though it was explained, what information do we get from the load curve? We get the maximum demand, we get the number of units generated, okay, and much more. But there are two or three more points which I didn't mention in the previous lecture. So in the today's lecture, first I will cover what information does the load curve gives. Okay, what information we are going to get from load curve. Okay, information from load curve. So let's suppose I'm drawing a load curve here. It is like this. Okay, so this is my power, that is in kilowatt, and this is time, which is in hours. So this will be a daily load curve. Okay, so first I will say that this load curve, it gives me the variation of the load, okay, during the different hours of the day. First point, variation of load during, okay, different hours of a day. Different hours of a day. So you all know that, because at particular instant, so this is 12 in the evening, then we have 1 in the evening, somewhere in the midnight, then 2, then 3, then we will have suppose 2 o'clock or 1400 hours at the midday. So it will be like this. So it gives us variation of load during different hours of a day. So what is the second? So the variation is like this. The second is when this point, the information. Okay, so the peak of this curve, what is this peak? Peak means maximum demand. So the peak of the curve represents the maximum demand on the station. represents the maximum demand on the station at any particular instant of time, or at any particular instant of time on any particular day. Represents the maximum demand on a station at any time on any particular day, on any particular day. Second point. So what is the third point? So look, what is this area under the curve? Okay, the area under the curve is this portion. So the area under the curve, it will give you what? The area under the curve will give you the total numbers of units generated, but which units? In kilowatt hour. Okay, so area under the curve, gives the total number of units generated. Gives the number of units actually generated. So this is third point. So once you get the total number of units actually generated and you know what is the peak, okay, then what will you do? Then the area under the curve, this curve, okay, divided by the number of hours, it will give you what? It will give you the average load or average demand. So area under curve divided by time in hours gives you the average load or average demand. So what is the last point? So just look here. What is load factor? Load factor is nothing but average demand, okay, which you get area under the curve divided by the total number of hours. It is called as average demand, okay, divided by the area under this rectangle corresponding to the peak load. So it will give you what? It will give you the load factor. Okay, so I will say ratio of area under the load curve to the total area under the rectangle to the total area of rectangle, okay, total area of rectangle corresponding to maximum demand, okay, it will give you load factor. Okay, so these are the 5 important informations which we get from a load curve. Number 1, variation of load with respect to time, maximum demand, total number of units generated, then total number of units generated divided by time in hours. It will give you what? It will give you the average load, okay. Then this area under the curve, this curve, load curve, divided by the area of the rectangle corresponding to the maximum demand, it will give you nothing but load factor. So these are the 5 important points or 5 informations which we will get from the load curve. So next I will explain 1 or 2 terms. Next term is demand factor. Demand factor. So demand factor is nothing but the ratio of actual maximum demand actual maximum demand is nothing but maximum demand, ratio of actual maximum demand to the total rated load connected to the system. connected to the system. Okay, so what I am saying, it is the ratio of actual maximum demand divided by the total rated load connected to the system. And you know that whatever is the total connected load to the system, it is not necessary that all the load will be on all the time. Okay, so out of the total connected load, total rated load that is connected to the system, a few of the loads may be kept on and few of the loads may be kept off. Okay, am I speaking right? No, I am committing a mistake here. So I am saying this demand factor, it should always be less than unity. Less than unity. So less than unity means denominator should be more and numerator should be high. Okay. So this is I am saying total connected load. This load can be sum of the load, that is I am saying in the denominator total rated load connected to the system. So out of this total rated load, some can be on, some can be off. Means suppose I have 1000 megawatt of total load connected to the system. So maybe out of 1000 megawatt of load that is connected to the system, maybe 800 megawatt is on and 200 megawatt is off. But the total that is connected to the system, it is 1000 megawatt. Okay, so this is actual maximum demand. So what will be the maximum demand on a system at any particular instant of time? Okay, so this actual maximum demand ki presently kitna on hai? ओके, एक्चुअल मैक्सिमम डिमांड कि अभी प्रेजेंटली जो है मेरा सिस्टम में कितना डिमांड है मैक्सिमम और प्रेजेंटली कितना ऑन है डिवाइडेड बाय द टोटल. ऑब्वियसली द टोटल विल बी मोर देन द एक्चुअल मैक्सिमम डिमांड. सो because of this, the numerator will be smaller as compared to the denominator and demand factor will be less than unity. Okay, so next term was installed capacity. Installed capacity. So let us solve this. Look what is installed capacity. So installed capacity means suppose we have a whatever generation we have available. Okay, so that summation of all the generations that is available, it is called as the installed capacity. So I will write it like total of the total of the station capacities, like this. The total, I will write it, the total of the station capacities available to supply the system load is called installed capacity. Okay, suppose I am saying like if I will talk that, suppose that I have three plants. Okay, I have three plants. Suppose I have three plants. So each in one plant I have four generators, each of 100 megawatt. In the second plant I have two generators, each of 150 megawatt. And in the third plant I have three generators, each of 150 megawatt. So summation of the total of the station capacities, the total of the, so in this station, first plant, I have four generators, each of 100 megawatt. So the capacity of this plant is 400 megawatt. So the capacity of the second plant, 150 megawatt each generator, and we have two generators, it is 300 megawatt. And the capacity of the third plant, it is 450 megawatt. Okay, so what is the total, what is the installed capacity? Installed capacity is the total of the station capacity. So we have to take the total of these three units. So 400 plus 300, 700, 700 plus 450, it is 1150. So I will have a installed capacity of 1150 megawatt. So I have an installed capacity of 150 megawatt, 1150 megawatt, but it may not be generating 1150 depending upon the availability of the fuel, depending upon the availability of the water. If the water is available, sufficient water is available, I may operate the 4 generators in this plant, 3 in this and 2 in this unit. But if the availability of the water it is slightly reduced, so what I have to prioritize my generation. So what I will do, maybe I will say, okay, I will keep these 2 units, these 2 plants on, means 3 generators from plant number 3 and 2 generators from plant number 2. And however, in case of plant number 1, I will keep the only 3 machines operational. Okay, because only because the quantity of the water it is reduced. If the quantity of the water will further reduce, I will turn off 1 more unit. Okay, so it is saying we have an installed capacity, but it doesn't mean that this system or power station it will be working on its installed capacity all the time. Okay, not necessary. It can generate. It can generate. It has the capacity to generate 1150 megawatt. But depending upon the availability of water, or if it is a thermal power plant, depending upon the availability of coal, maybe it will generate 1150 or slightly less than 1150, but not more than 1150. Okay, because it is the installed capacity. We cannot go beyond the installed capacity. Okay. So then one more term is there which is called as dump power or dump load. Dump power or dump load. So what do you mean by dump? Dump means anything which is in excess and you want to get rid of that thing. Okay, that is called as dump. You will dump that. Suppose I am saying that my load is 100 megawatt and my generation is 110 megawatt. This is my load and this is my generation. So what will happen? There is a mismatch of 10 megawatt between the generation and load. So because of this 10 megawatt excess generation, the speed of the frequency of the system will increase. Okay, so what is the desirable thing here? The desirable thing is that we have to we have to dump this extra 10 megawatt of generation, so that if we are dumping 10 megawatt of generation, then generation will be 100 megawatt and load is again 100 megawatt. So frequency will be constant at its rated value. So but because of the excess generation, some dump power is available. So what we will do, we will dump this power. Dump power means we don't need this power. Suppose in summers, I will give an example. Suppose in summers we don't need these water geysers. Okay, we don't need water geysers, but in order we want, okay, because we have excess power available and we want to dump this power, what we do? So what we do, we dump this power means we turn on the geysers or boilers. Okay, so that way that power is wasted. Okay, though we don't need the hot water, but still in order to keep the system stable, we waste some power there. Okay, so that is called as dump power. Okay. So next, let us solve a few numerical problems. So, because we haven't solved any numerical as of yet till now. So let us solve 3 numericals, 3 or 4 problems, depending upon the time availability. So first, I am saying, yep, here I have a question bank. So this is a problem number 1. So I am saying that we have load. Okay, we have lightning load. Okay, we have fan load and we have refrigerator load. Okay, what is the light load? We have 6 tube lights, and each tube light is of 40 watt. Okay, and for how many hours we are turning these lights on? We are turning these lights on for 4 hours daily. रोज 6 बल्ब हम जलाते हैं, 6 ट्यूब लाइट्स जलाते हैं. 40 वाट की एक ट्यूब लाइट है, तो 6 4 जार 240 वाट्स. और कितने घंटे तक चलाते हैं? 4 घंटे. सो कितने वाट आवर हो गया? 240 मल्टीप्लाई बाई 4. These are the units consumed due to light load. So fan, we have 6 fans. Each fan is of 100 watt, and again we are running each fan for 6 hours. Okay, so 6 multiplied by 100, 600 watt, and we are turning the fan on for 6 hours a day. So 600 multiplied by 6, you will get the itne watt hours respectively. And you have a refrigerator of 2 kilowatt hour and means daily continuously on hota hai. Then you have a miscellaneous load of 2 kilowatt for 2 hours daily. Miscellaneous means suppose you are charging your mobile phones, okay. You are using your computers means for a small means fraction of seconds or maybe for few minutes you are turning on your these mixer grinders or other objects, toasters, okay. So that is considered, I am considering it as a miscellaneous loads of 2 kilowatt for 2 hours, okay. So what is the question? The question is find the monthly bill at the following rate. So what is the rate? That for first 20 units, the rate is 50 paisa per hour. And for the next 30 units, the rate is 40 paisa per hour. And for the remaining units, the rate is 30 paisa per kilowatt hour. Please note the units per kilowatt hour. Okay, so here you have in watts, you have to convert these watts into kilowatt hour. Then you have a constant charge of 2.5 rupees 2.5 per month, means even if you are not using any electricity, still you will pay this 2.5 rupees 2.5 per month. Okay, if you are not using any electricity, still you have to pay rupees 2.5. This is the constant charges. And a discount for prompt payment is 5%. If you will pay within the due date, then you will get a 5% of discount. So how I will solve this problem? Look, I am saying, look here, how many bulbs are there? Solution, I will write down the solution. First, I will calculate the total load. Okay, total load per day. Okay, because we are asked the monthly bill na, and these details they are on daily basis details are given to us, है ना? So how many? So I am calculating total load per day. These are 6 tube lights, each of 40 watt. 6 multiplied by 40. Then this will give you the power rating of the 6 tube lights. Okay, and for how much time you are for 4 hours, so multiply by 4. So this will give you the power or that energy that is consumed by the 6 tube lights in 4 hours. Okay, similarly the energy consumed by the 6 fans in 6 hours will be this. Okay, plus the refrigerator load is 2 kilowatt hour, it is fixed, and plus the miscellaneous load is 2 kilowatt hour, 2 into 10 raised to power 3 for 2 hours a day. Okay, so these are the details which are given to me. So I have to convert, please note down that these two quantities, they are in watts. So I will convert it into kilowatt, and I will omit the 10 raised to power 3 sign here, and I will again convert this again into kilowatt. So these two quantities were in watt, so I have converted it back to kilowatt. So where is my calculator? I don't have the calculator, so I have to do some manual calculations. So luckily I have solved these things here. So it is 6 multiplied by 40 multiplied by 4. If I will solve it, 6 multiplied by 40 multiplied by 4 plus 6 multiplied by 100 multiplied by 6 whole divided by 1000. Okay, plus 2 kilowatt hour plus 2 twos are 4 kilowatt hour. Okay, so it will be around what it will be. So if I will solve it, so it will be 240, 6 4s are 24. So I will do some rough here. 240 multiplied by 4, 0 4 6 960, 960 plus 36 multiplied by 100, 3600 divided by 1000 plus 6. So it will be 3600 plus 900 will be 4560 divided by 1000. It will be 4.56. Okay, so if I will solve this part, it will be 4.56 plus 6. So my total daily load will be 10.56 kilowatt hour. So this is my daily load consumption. Okay, so what will be monthly load consumption? Because we pay electricity bill on monthly means na basis. So monthly consumption will be Monthly consumption will be daily load consumption multiply by 30. Considering I am considering that I am taking 30 days in a month, so it will be, if I will solve it, it will be 316.8 kilowatt hour. Okay, so this is monthly consumption. So this is my monthly 316.8 kilowatt hour. So next, let us see what are the charges. So charges are for 20 units. For first 20, it is 0.5 paisa. For next 30, it is 0.4 paisa. Remaining units, it is 0.3 paisa. Okay, constant charge is 2.5 rupees per month. Okay, so how many units are there total? 316.8. So let us solve this. So my monthly bill will be so for the first 20 units, how much is 20.20 multiplied by 0.5. For the next 30 unit, it is 0.4. So how many units are remaining? Total are 316.8. Out of 316.8, 50 मैंने निकाल दिया बाहर, क्योंकि पहले फर्स्ट 20 का रेट क्या था? इट वॉज 0.5, and for the next 30 the rate was 0.4. So 30 plus 20, 50. So take 50 out of this 316. So I can write it here like this: 316.8 minus 50. Okay, so these are the remaining units, and the charge for the remaining units is 0.3. Okay, so plus 2.5. So what will be my monthly bill? It will be 10 plus 12 plus if I will solve, I will get it 80.04 plus 2.5. So if you will solve, you will get rupees 104.54. So this is your monthly bill. Okay, so bill after the discount. What is the discount? Discount is 5%. So bill after discount will be discount of 5% will be 0.95 multiplied by 104.54. So the bill will come around 99.313 rupees. So this is your monthly bill, 99.313. Easy so far? Okay, so the first problem is always easy, because the first problem is just to show how to start the process. So now let us move to the second numerical. So I am going to write down all the details about the second numerical here. So this is the problem. So we are saying that a consumer has an annual consumption of 70080 kilowatt hour. So this is the yearly consumption. So what is the yearly consumption? So let's first write total load, total units consumed is nothing but 70080 kilowatt hour. So these are the total units consumed. So the charge is, so the charge, it is cost or charge, it is saying is nothing but rupees 100 per kilowatt of maximum demand plus 5 paisa per kilowatt hour. Look, this means the charge is rupees 100 per kilowatt of maximum demand plus 5 paisa per kilowatt. Means this is a two-part tariff. Means first, the consumer is charged for the units that the consumer consumes. Okay, and the rate is 5 paisa per kilowatt hour. So depending upon how much kilowatt hour it is consuming, you will multiply it by 0.5 by 5 paisa, and you will get the one part of the tariff. The second part of the tariff depends on maximum demand. What is your maximum demand of a consumer? So it is rupees 100 per kilowatt of maximum demand. So if your maximum demand is 5, so it will be 100 multiplied by 5. So if your maximum demand is 10 kilowatt, it will be 100 multiplied by 10, because it is charging rupees 100 per kilowatt of maximum demand. Okay, so this is two-part tariff. One is maximum demand tariff and another is the unit consumed tariff. Okay, so this type of tariff is called as two-part tariff. So what is the, let's move further in the question. The first part of this question is like, find the annual bill and the overall cost per kilowatt, means yearly bill and cost per kilowatt hour if load factor is 40%. Okay, and the second part, what is the overall cost per kilowatt, overall cost per kilowatt hour if the consumption was reduced by 25%, if consumption was reduced by how much, 25% with the same load factor. Okay, so I will again explain the problem. So we are given the total units that are consumed by a consumer in a year, and we are given the cost or charge, how the consumer is charged. The consumer is charged like rupees 100 per kilowatt of maximum demand plus 5 paisa of the plus 5 paisa per kilowatt hour. Okay, this way we are going to charge the consumer. This is a method which we are going to charge the consumer. And the first option is that we have to find the annual bill or yearly bill and the cost per kilowatt hour if the load factor is 40%. And again we have to again calculate the overall cost per kilowatt hour if the consumption was reduced by 25%, keeping the same load factor, means 40%. Okay, so now let us start the process of solving this problem. So what is the total energy, total units consumed? So I am saying total units consumed is nothing but 70080 kilowatt hour. Please write units at every step. Okay, what are the units? Because at the end you will face problem. So these are the total number of units which a consumer consumes in 1 year. Okay, so and you know how many hours are in a year? Number of hours in 1 year. Number of hours in 1 year is nothing but 8760 hours. Okay, so you have the total units consumed, you have the total hours. Can you calculate the average load? Simply average load. This is the only step that makes this that solves the whole numerical problem, is you have to calculate the average load first. So total units consumed divided by total number of hours in a year, it will give you the average load, which is coming around 8 kilowatt. So you know what is your average load. Got it? What do you want to calculate? You want to calculate the maximum demand, because your cost depends upon the maximum demand. You have the total number of units consumed, kilowatt hour you have, but you don't have this maximum demand. So you have to calculate this maximum demand. For calculating maximum demand, you have load factor. Since the load factor is given, what do you need? You need average load. Okay, and how can you calculate average load? Average load you can calculate simply from the total number of units consumed in a year. So once you know the average load, you know the load factor, you can easily calculate the maximum demand, because you know that load factor is nothing but average load divided by maximum demand. So which implies maximum demand will be equal to, what is load factor? 40%, 0.4. Sorry, I will solve it here. Max demand will be equal to what? Max demand will be equal to average load divided by load factor. So average load 8 kilowatt divided by load factor 0.4. So it will come out as 20 kilowatt. So look, what is the maximum demand of a consumer? It is 20 kilowatt. So for calculating the cost, you need maximum demand and the total number of units consumed. So you have the maximum demand. Now you can easily calculate the cost. So cost, or you can say annual energy consumption bill will be will be, what is the method? Rupees 100 per kilowatt. So for 1 kilowatt we are for 1 kilowatt of maximum demand we are charging rupees 100. So what will be the cost for 20 kilowatt of maximum demand? So it will be 100 multiplied by 20. Okay, because for 1 kilowatt of maximum demand, what is the charge? Rupees 100. So for 20 kilowatt of maximum demand, it will be 100 multiplied by 20. First part. What is next? Plus. So plus 5 paisa of 5 plus 5 paisa per kilowatt hour. So how many 5 paisa will means 0.05? Yes, 0.05. Because in 1 rupee we have 100 paisa multiplied by this is 5 paisa, this is per kilowatt. For 1 kilowatt hour we are paying 5 paisa. So for 70080 kilowatt hour we are paying how much paisas? 0.05 rupees multiplied by 70080. Got it? So what is the bill? The bill will be, if you will add these two, it will be 2000 plus so bill will be around 345,504 rupees. So first part solved. So this is the first part. The second part, what was the second part? The second part is what was the overall cost. So this is your yearly bill, but we have to calculate first what this is. Yearly bill we calculated. What is the second one? The cost per kilowatt hour. So cost per kilowatt hour or cost per kilowatt hour will be total cost 5504 divided by total kilowatt hour 70080. Okay, so this will give you cost per kilowatt hour. So if you will multiply it, you will get it around this 7.85 paisa per kilowatt hour. So this is the first part. These two things, calculating these two things, you means finished your first point. Okay. So the next point is, what is the overall cost per kilowatt hour? Okay. If the consumption was reduced by 25% with the same load factor. So means earlier consumption was 70080 and now the consumption is reduced by how much? 25%. So it will be my annual consumption now will be, annual consumption will be how much? 1 minus 0.25 into 70080. It will be simply 75% of 70080. So if you will solve it, you will get it as 52560 kilowatt hour. Now this is your consumption. Now you have to calculate the overall cost per kilowatt hour for this consumption now. Okay. Now what will be the average load? You know this use your annual consumption. So first of all, let us calculate average demand or average load. Average demand will be simply 52560 divided by how much? How many years? 8760. So it will be around 6 kilowatt. This is your average load. So load factor is same 40%. So your maximum demand will be 6 divided by 0.4. Okay, so it will be 60 by 4. It will be 15 kilowatt. Now your annual energy consumption bill it will be what is the maximum demand? 15. And what is the 15 kilowatt, and what is the cost per kilowatt? 100. So for 15 kilowatt, it will be 100 multiplied by 15 plus 50 paisa for 1 kilowatt hour. So it will be 0.5 paisa, 0.05. And what is the total? How many kilowatt hours are consumed? 52560. Okay. So it will be rupees, if you will solve it, 4128. So this is your annual energy consumption. ओके कि एक साल में आप यस, एक साल में आप कितना बिल देते हो. Okay, so you are paying this much bill for these many units. Okay, so this much bill for these many units, so cost per unit will be total bill 4128 divided by total units 52560. Okay, 4128 divided by 5.560, so it will be around 7.85 paisa per kilowatt hour. So this is your second part. Easy. So what was the cost per kilowatt hour? Look, an important means I want to say means show something very important here. Look, when the load factor was 40% in the first case and the load factor was 40% in the second case as well. Okay, and what happens in the second case? Only the total number of units that were consumed, they change. Total annual energy consumption, it changes. Okay, but the load factor remains the same. So tell me, what is the cost per unit or cost per kilowatt hour? In the first case it was 7.85 paisa per kilowatt hour. So what is the cost per unit in the second case? It is again 7.85 paisa per kilowatt hour. Why? You know that annual bill, it changed. Earlier in the case first, the annual bill, it was around, where is the bill? It was 5504, and here it was the annual bill was 4128, but the cost per unit, it is same, 7.85 paisa here and 7.85 paisa here. Why? Okay, this is because in both the cases the load factor was same. It was 40%. If the load factor is same, then the cost per kilowatt will remain same. Okay, so thus I can say that the cost per kilowatt hour, it remains same in both the cases, because in both the cases the load factor was constant. Okay, though the energy consumption and maximum demand are reduced. Okay, energy consumption here is reduced, the maximum demand here is reduced. Okay, though the energy consumption and maximum demand are reduced, okay, but the this cost per kilowatt hour, it remains same. Okay, so what you will do, you will solve the same problem, but third part I am saying the load factor was constant. Okay, so what you do in the third case, take case number third, keep the same load factor and reduce the number of units consumed by 40%. Okay, what I am saying, in this third case, you will keep the load factor same, which is 40%, but you will reduce the number of units consumed by 40%. Here you are reducing by 25%. In the third case, you will reduce by 40%, and you see again the cost per kilowatt hour, it will come same, 7.85 paisa per kilowatt hour. Okay, so this is your homework. Do check it and then realize, because of this same load factor, the cost per unit, it will not change, it will remain same. So I think that is enough for today's lecture. So I have already exceeded this 43 minutes. So do watch these videos, and in case of any confusion, call me within the working hours on the working day. Thank you very much.